Hi, today I will focus on some bioinformatic terms like ortholog, homolog, and paralog. Actually, my focus is basically on Genomicus tool, but before going to elaborately explain how you can use Genomicus tools to find duplication node and what is the meaning of this duplication node. So just have a quick review for what is ortholog, homolog, and paralog. So the term is ortholog, homolog, and paralog. Let's consider a gene we call X. Okay. So evolutionary, it become separated to two species. Consider this is bacteria, and this is yeast, and this is another fungi. So here you can see this same gene is divided among two species, but within a different version. We call it gene speciation. So creation of new species, and here we will say that these two are ortholog. So ortholog occur after speciation of genes. Now let us look what is paralog. Consider the same gene X. Evolutionary, it became integrated as X1 and X2 of the same species. We call this duplication. In same species, so it is called paralog. So see the difference. For ortholog, it becomes speciation, same version of the gene in different species, but for paralog, two copies of the same gene in the same species. So just consider it as human or zebrafish. Now, if we consider that X1 get another version of X1A and X1B, same for X2, we got X2A and X2B. So consider this is another organism, this is another new organism. So here speciation occurs. So mind you, speciation is always means new organism or new creation. So what can you conclude from X1A and X1B? So what is the relation between X1A and X1B? What do you call it? Ortholog, paralog, or what? As X1 is divided into X1A and X1B, and they are not in the same organism, they are in different organism. If you consider this is dog and this is fish, so you can say this is ortholog. And if we consider what else we consider, for example X1A and X2B, we can call them homolog because they all are evolutionary conserved to, for example X2B or X1A, these all are conserved X to home X. Okay. So when something is ancestrally conserved, we call it homolog. So now let's go for my interest. So today my interest is on explaining how Genomicus tool can be used to explain what type of genomic duplication. I mean, there may be two kind of duplication. One is localized gene duplication, and another may be whole genome duplication. So first of all, let us go Genomicus. Just go to Google, type Genomicus. Here we go. So this is the Genomicus website. I'm not going to explain detail about how Genomicus works and what are the other queries mean of a Genomicus tools, because all of this explained in the website. You can find this in help and documentation menu. But one thing I want to explain here that they didn't explain what is the meaning of duplication node, and how duplication node, from how one can say this duplication node means localized gene duplication, and it is whole genome duplication. Let's consider gene LRRC56. My interest is Homo sapiens. Click go. There you go. So this is the window of this is the outcome of Genomicus. So I'm not going to explain every tool because this is nicely explained by Genomicus in their video. So look at there. Okay. Here is our human. So this line is our reference line, and we are comparing this gene, how it become ortholog or homolog or paralog. If you go down, you can see one red rectangle. So this red square is nothing but meaning of gene duplication. Here when you click here or just place your mouse here, you can see two green buttons. One is in left, one is in middle. So in the same chromosome you can see two duplicated versions of the human LRRC56 gene. So it means that they are parallel. So this is in zebrafish, I guess. Yes, this is in zebrafish chromosome 25. Or for considering second one, it is same thing, zebrafish chromosome 25. But don't be confused, it is not a genome duplication, it's just a localized gene duplication, because gene is duplicated in the chromosome, in the same chromosome. Okay, so these two, the first one and second one, both are same chromosome. Because of their algorithm, they are showing here differently, and they each time compare the gene. So they find two genes in the same chromosome. So once they consider the first one, and another time they consider the second one. That's why it is showing the two chromosome, I mean chromosome 25. So I think that's clear. So in a nutshell, localized gene duplication is the duplication of gene in the same chromosome, and whole chromosome duplication is the duplication of gene in different chromosomes. For example, it's maybe in maybe in zebrafish chromosome 1 and chromosome 3, but you can see this both are in chromosome 5, in the same chromosome. So I think that confusion is clear now. So we can say that LRRC56 is nothing but localized gene duplication in zebrafish. Thank you for watching. Bye.